So here we have the question of sketching all the minor trigonometric functions. But just for the sake of completion, I'm going to sketch sine and cosine as well. They're all based off of that. So here we have the graph of sine. It goes up to 1, down to -1, over to 2 pi. And then cosine, this, same thing. And if you know that, you can create the others. So let's start with tangent and cotangent. So tangent is a reciprocal, is sine over cosine. So if you're going to go, let's see, it says minus 2 pi to 2 pi. Alright, so one thing we want to know is, where is this guy 0? Alright, so tangent of x is going to be 0. It's going to share the zeros with sine of x. Okay, done. Well, we also know it's going to have asymptotes where cosine is 0. And the cosine zeros interlace the sine zeros perfectly evenly. So I'm just going to put dotted lines to indicate there's asymptotes there. Okay, and then the next piece of the instruction says be sure to label where y equals 1 and y equals -1. Okay, so this is fine, just putting a tick mark. But then it means the function has to lie in the appropriate place there. We know tangent of 45 degrees is tangent of pi over 4, which is 1, because sine of pi over 4 equals cosine of pi over 4. This is like a little thing you should have stuck in your head. And so pi over 4 is halfway to these asymptotes, so it's going to be right here. And then it just spirals down that way. And so halfway between these, the asymptote and the root, the function's either going to be 1 or -1. And once more. There we go. Wait, one more piece. And it says clearly label all multiples of pi over 2. So I got to go through and do that. Okay, let's go ahead and do that. There's pi minus pi, pi over 2, 3 pi over 2, minus pi over 2, minus 3 pi over 2. Okay, let's do the same thing now for cotangent. Alright, that's all we need to do. So cotangent is going to share zeros with cosine. So if this is 2 pi, this is minus 2 pi, then what we have is actually asymptotes there. Actually, it's easier to label the asymptotes for this one first, because sine of x just divides more nicely, right? Because the zeros of sine of x are 0, 2 pi, -2 pi, and pi. So all the first break, as it were. And then cosine is the break that comes in between. So cosine are the zeros that come in between the asymptotes. Okay. Oh yeah, so cosine is reciprocal of tangent, so cotangent is reciprocal of tangent. So cotan of 45 degrees is also equal to 1. So that's neat. We're going to mark 1 and -1. So all these, in between the dots and the asymptotes, again, you're either going to be 1 or -1. So the question is this curve tipping up or tipping down? But see, if this is over here pi, and this is pi over 2, then at pi over 4, cotangent has to be 1. So you're actually going to swipe this way. Okay, so this is kind of a bad plot, but here we go. That works. Okay, and again, we got to go through and label all these guys. Minus pi, pi, 3 pi over 2, pi over 2. I guess I could use a finer width that you could see better. Okay, I think everything's there. We can go to the next questions, and I'm going to just cut these guys out so that I can have the space back. Alright, now what I'm going to do is I'm going to plot secant and cosecant. Alright, so again, pi over 2. So let's break this up. And the first one I'm going to do is secant of x, which is 1 over cosine of x. So what I can do is I can draw the cosine curve and then erase it later. You're welcome to keep the cosine curve in there, I don't care. But say I have a 1 and a minus 1, which is requested. And the cosine curve looks like that. Okay. Now we just take the reciprocal. And so you can see wherever there's a 0 in the original function, you have to have an asymptote. Really? That's obvious. That's pretty easy. And the other thing, you know, reciprocal of 1 is 1. And so this piece just does that. Okay, reciprocal of -1 is just -1. And so I want you to think of this as just being some kind of funhouse mirror that stretches things in some strange, funny way. Okay, but 1 stays at 1, -1 stays at -1, and zeros go to infinity, but the sign stays, the SIGN stays the same. Okay, so we've got secant. Let's go ahead and do the same thing with cosecant. You'll probably get tired of drawing pies. Okay, so let's go ahead and draw cosecant of x, which is the reciprocal of sine of x. Notice it's not inverse of sine of x, it's not sine to the -1 of x. And we have a question later in the practice exam that does that sort of thing. Okay, so now what we need to do, we still need to label 1 and -1. And then let's go ahead and draw sine of x for our own reference. Here we go, there's sine of x. And so then we know that wherever it has a 0, and then the whole thing runs exactly the same way as what we just did for secant. Those curves are friends. Zoop. Shoop. 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 Now I can go ahead and erase this. There we go. All done.